Hello, welcome back to Probable Magic. This is episode number 30, and we are returning to the series Drawing on Probability for part 3, where we're going to start caring about A. Now, I know this is the least popular of the thread lines I'm pursuing, but still one that I care about and interested in talking about, and hope a few people out there may be interested in it as well. If you've seen the previous episodes in this series, we started by creating a probability of draw table in which, let's bring it up here, we said to use this table we had to divide our deck into two categories. The cards were either A or not A. And the example I've been using were lands and not lands. And not lands being spells. And in the past, we said we've got A and not A, and we don't care what A is. That we have lands and spells, and we don't care what those lands are. Well, now we're going to start caring about what those lands are, specifically for looking at a two-color deck. So we're going to look at, let's just call it mountains and forests for an example, and break that down. Now, just for transparency, I did make 2 changes to this spreadsheet off camera since the last time. I'm pointing this out because in this particular series I've been trying to do a lot of the Excel work on camera, so that you can try to follow along. 2 things I did off camera is I turned these labels into inputs. Before they just said lands and spells. Going forward I want these to be inputs, so that, and I've tied all of these to them. You can see this is tied. Instead of before, this was just typed out lands 1, now it's tied back to this cell with the 1 and so on, so that going forward when I change this, say to mountains, and this spacing is off, but it will go through and update that, and that's just going to be helpful to me when I start looking at different cases. So I wanted to go ahead and make that change early. The other thing is that I had brought this graph when we looked at our probability distribution for lands in our opening hand. I had put that onto a separate sheet. I brought it back for reasons that will be more clear later, so that when I make some copies of this sheet, each one will have a graph. Okay, so how are we going to go deeper on this? One thing we should point out, we said A could be anything. We used lands and spells, but for a two-color deck, if we just want to look at when am I going to get mountains, we can make A mountains, and if our deck is, say, 9 mountains, 8 forests, instead of this split here on lands and spells, we could make this mountains and not mountains, and say our deck is 9 mountains and 31 not mountains. And we could look at the distribution that way and say if all we cared about is when are we getting mountains. Same exercises with the 17 lands. We could look at our distribution for 9 mountains in a 40 card limited deck. How many are we likely to get in our opening hand? And see, still with a 7 card opening hand, we've got a good chance of getting 2 mountains is the mode there, with 1 slightly behind, 3 less likely, And we see if we mulligan even one time, the mode, the most likely single outcome, shifts from 2 to 1. And this red line of 0 in our opening hand is becoming a more significant possibility. So if all we cared about in looking at in this 2-color deck is getting that one land type, we've already got a tool for that. But that's probably not all we care about. We probably care about when are we getting both of our colors. So how are we going to do that with this tool? Bear with me a moment and try to follow along and picture this. Imagine if we have our 40 card limited deck with lands and spells, 17 lands, 23 spells, and those lands are some combination of mountains and forests. And we take those 17 lands out of our 40 card limited deck, and in their place we put 17 cards with identical card back and everything, and the front of the card just said draw a card from your land deck. And we took those 17 lands that we had removed and we shuffled them up and put them in a separate pile and called that our land deck. And now whenever we were drawing a card from our deck, if we get a card and it's our normal spell or creature or whatever, we just put it in our hand. And if it's one of these marker cards that we inserted that said draw a land from your land deck, we then just reach over to our 17 card land deck and take the top card off that. And we put that land in our hand and we just toss the marker card aside. Now, you're probably thinking that sounds like extra work and it's unnecessary and causes confusion. It's an extra step. Why would you do this? And all that's true. There's no reason to do that because it gets you to the exact same end state. But that's the important thing to realize, that just if you imagine doing that, the end result is exactly the same. It gets you to the same end state. And why are we doing that? Because that's essentially what we're going to do here with our spreadsheet. We are going to pull these 17 lands out and put a token in their place that says draw a card from your land deck. And now we're just going to copy this entire spreadsheet. And now this is our main deck. This is our land deck. And now this deck consists of still A and not A, but in this case we have mountains and not mountains, and I'm going to, for tonight's purposes, assume that I've only got two basic land types. I've got mountains and forests, and we'll start with 9 mountains and 8 forests. All the math exactly the same, right? We just copied everything over. We're still dealing with a deck of cards that has cards of type A and not A. It still doesn't matter what they are. We're just drawing our box around the system differently. So we have our main deck, 40 cards consisting of lands and spells, A and not A. And then if we're looking at just these 17 lands, we can break that down into A and not A, mountains and forests. Some of these cells, you see this divide by 0 error. That's just because we had set this up to go all the way up to 40 cards, and now we're dealing with a 17 card deck here. Doesn't matter. So I made that pulling the card out illustration for clarity. We don't really need to pull the cards out. You can do this exercise Uh, Picturing it just as focusing in on those 17 lands, I think it just helps to try to picture it as pulling it out into a separate pile. And now we can look at this same distribution that we had set up before, distribution calculations. This really isn't hand size anymore. Now this is land draws. So before, when we just put mountains into our A category before, we could look at how many cards we had to draw to get a given number of mountains. Now when we're looking at this land deck, the way we're looking at this is how many lands do we have to draw to get to a given number of mountains. So I draw one land, my first land, top card off my land deck, or if I'm just, in reality, I have my 40 card limited deck with 17 lands in it, and 9 of them are mountains, 8 of them are forests. The card draws don't matter until I get to that first land draw. Well, I've drawn one land. There's a 47% chance that I have 0 mountains, 53% chance that I have 1 mountain because of the 9-8 split. Once I've drawn 2 lands out of my 40 cards, there's a 21% chance that I have no mountains, 53% that I have 1 mountain, and 26% chance that I have 2 mountains. And we still have this distribution curve set up. It only goes out to 7 just because that's the way we set up the graph before. You could extend that out however far. Really, for a limited game, we're kind of looking at the early part of the game. Getting to 7 lands is generally going to be good enough for us. So one of the things we can do with this, say, we care about when are we going to hit double red, or say we're playing M14, and in one of the drafts I did, not the most recent one, I think the one before that, I had 2 Awaken the Ancients in the deck, which is a pretty powerful card in a red heavy deck. But you have to be red heavy because the casting cost is 1 red, red, red. So we need to get to 3 mountains to be able to cast that card. Well, how many lands do we expect to need to draw on this 9-8 land split to get to 3 mountains? If we just draw our first 3 lands, you actually need 4 lands total to cast that, but just, if we get to our first 3 lands, the most likely result, the mode, is that we'll have 2 mountains. So then 1 forest. And we can look at this and see that it is at least twice as likely that we will have 1 mountain and 2 forests as it is that we would have 3 mountains. And less likely than that would be 0 mountains, meaning 3 forests. So one of the things we could also look at with this, as long as we can interpret the data in the right way, is when are we hitting having both colors? How many lands do we have to draw to have at least 1 mountain and at least 1 forest? So let's see what cells are we looking at for that. We're not looking at one land draw. I'll just gray that out because we know if we've only drawn one land, we don't have both of our colors. We also know we don't need to bother looking at 0 mountains, because if we have 0 mountains, we don't have both of our colors. And if we have if we've drawn 2 lands, the case where we have both of our colors is if we've drawn 2 lands and have 1 mountain. If we've drawn 2 lands and we have 2 mountains, we do not have both of our colors. Likewise, if we've drawn 3 lands and we have 3 mountains, we haven't hit our second color. 4 lands and 4 mountains, and so on. It starts to become kind of meaningless down here, but still. So we can see this area. I shouldn't use yellow because that's the color I've been using for inputs, and this is not an input. This blue area represents the probability that by a certain land draw, and this, remember, this is not card draw out of our 40 card deck, this is the number of lands we've hit, that we will have hit both of our colors. So with this fairly even split, 9-8 split, when we get to our second land draw, whenever that is, there's a 53% chance that we have both colors. When we get our third land draw, we have to add these up. That's 79% chance that we have both our colors. Let's go ahead here and sum it up for convenience. Both mountain and forest. I don't know a good way to kind of set this up to do the calculation correctly as I drag it down, so I'm kind of doing it manually. So those are the odds that by a given land draw we will have both one mana or more, one or more mana of both our colors in this 40 card deck with 17 lands, 9 mountains, 8 forests. We start at 53 with 2 lands and increasing up from there. So depending on your deck and how certain you want it to be to hit both colors by a certain land drawn to the game, you could judge your likelihood from this. You say, well, I want to have at least a 90% chance of hitting both my colors. How many lands do I need to draw to have a 90% chance of getting both colors? I need by 4 lands in, I have a 90% chance of both colors. Say, okay, this was for a 9-8 split. Let's go ahead and copy those values. we said, we're a red heavy deck, and we're more concerned with mountains, what happens if we turn this into 10-7? And we can see at 10-7, what are we giving up in likelihood to hit both of our colors? Not a whole lot. 2% in the beginning, and down to 1% later on. So if we're a red heavy deck, and that's really what we care about, we're willing to take on a little more risk of not having that second color quite as early. Could make sense to go 10-7 instead of 9-8. Other thing we could look at that's based on 17 lands, we could say, well, how much better does it get if we go 9-9? I hadn't copied that over, 10-7 over. We see it 9-9. Basically, chance is exactly the same as 9-8. If we went 11-6, now we start to lose a lot on the odds of getting that second color. So that's part of the power of this tool. But the other thing we can do is we probably don't, in reality, we don't care how many land draws we have to be to get to this state. We want to know how many card draws we have to be to get here. So let's go ahead and put this back to 9-8. Done with that. That's 0%. We said, right, we can't get to both a mountain and a forest on one land. So how many card draws in do we have to be to get to a mountain and a forest? Well, let's go back over here to our main deck and just reference these cells. Just going to copy the formatting over. And actually that's not quite what I want. What I want to do is copy this, come up here, paste special, transpose. And that didn't work the way I meant it to. What I'm going to have to do is both mountain and forest with 0 lands. There's a 0% chance I have both. On one land, there's a 0% chance I have both. This, I think, maybe a better way to do this. At the moment, I'm just putting in these individual references. There we go. Sorry about that. That's one of the risks in trying to do everything on camera. with this kind of thing. Sometimes that happens. Things don't work exactly the way we expect them to. See, so now this is my heading there. So with a hand size of 1, I've got a 58% chance of 0 lands, 43% chance of 1 land. And this up top here is the probability on 0 lands that all have at least 1 mountain and 1 forest. 0 for these first 2, obviously. So I can look at, for a hand size, what is odds of both mountain and forest. I can do that by saying this is where we have the probability of 2 independent events is the probability of event 1 times the probability of event 2. So for a hand size of 1, there's a 58% chance of having 0 lands, and if that happens, the odds of me having 1 of each is 0%. Plus, here we get into the OR rule of probability where we add them together, or there's a 43% chance of 1 land, in which case there's a 0% chance of having 1 of each. And we can just go all the way down the line like that. Not meaningful for some of these. I hate when that happens. I'm going to drag this over here, just get out of my way, make it easier, and then I'll move it back. So these are all 0 for land 1, but the reason we're doing this, of course, is so that then we only have to do it once, and we can just drag the cells. But all these that are in row 4, we need that not to move. Oops, erased my 4. When we drag it down, so I need a $sign in front of all those references to row 4. I can drag that down, and now this represents the probability that I will have in my opening hand at least 1 forest and 1 mountain. You can see, of course, if I have a 1 card hand, it is impossible that I could have 1 mountain and 1 forest. If I just draw the top 2 cards off my library and I have a 2 card hand, there's a 9% chance that those top 2 cards off my library were 1 mountain and 1 forest. Because there was a 32% chance that that neither of the top 2 cards off my library were land. And then there was a 50% chance that only one of them was a land, in which case it doesn't matter what it was. And there was a 17% chance that the top 2 cards off my library were both lands. Right? And that's requirement 1. If I'm going to get the top 2 cards off my library to be a forest and a mountain, they both need to be lands. And that, if you recall, if we were to add up all these for any given hand size, it would go to 100%. You know, we've got some rounding errors that make it look like it's not here. But if we show another decimal point, that's a little better. You still got rounding errors, but it adds up to 100%. So 17% of the time in a 2-land hand, in a 17% of the time in a 2-card hand, both of those cards would be lands. And of that 17% chance, 53% of the time, it would be 1 mountain and 1 forest, based on a 40-card limited deck with 17 lands, 9 mountains, 8 forests. So overall, we're starting out with our 7-card opening hand. We've got our distribution for how many lands we are likely to have in that 17-card opening hand, and we have most likely 3 or 4 lands. And with those 3 or 4 lands, well, over this entire curve, really, that 7-card opening hand, there's a 76% chance that we're going to have at least 1 land of each color in this 2-color deck. So there you go. That's some of the power of this tool, and we're going to be going further on this as we go forward. Hope that made sense. I know there's some points where I was tripping over my words a bit to explain it all, but hope you could follow along. This has been Drawing on Probability with Probable Magic. I will see you next time.